So good morning everybody. Sorry I can't be with you today. So today's lesson is going to be on solving nonlinear inequalities. So all of you should be familiar with solving linear inequalities. What we're going to concentrate on today is how we can solve quadratic or rational inequalities, so second degree or higher rational expressions. So we want to solve polynomial and rational inequalities. The steps we're going to take is, first of all, we want to make sure the setup is the easiest way to solve these. So what we want to do is make sure you write the inequality so that the polynomial rational expression f is on the left-hand side of your inequality sign. So make sure that you put all of your expressions and terms on the left-hand side, and then you want to make sure the 0 is on the right-hand side. So it's going to be in the following form: your f of x be greater than or equal to 0, or f of x to be greater than 0, or f of x is less than or equal to 0, or f of x is less than 0. So make sure you put the 0 on the right-hand side. Once you have this particular setup, what you're going to do is you're going to factor and determine the numbers at which your expression on the left-hand side is equal to 0. So basically you're going to factor, you're going to set everything equal to 0 and go ahead and solve. And if it's a rational expression, not only are you going to set where it's equal to 0, but you also want to find where it's undefined. And remember, when you have a rational expression, this would come from by setting the denominator equal to 0. And when we find these particular values, these are called the critical numbers. Once we find these particular values, what we're going to do is we're going to plot them on the real number line, which will divide the real number line into intervals. And then what we're going to do is we're going to select a test number in each interval and substitute into, again, the factored expression. Determine the sign. You don't have to actually find what the actual number is, but we're going to determine the sign. So what's going to happen is the value of f is positive, then f of x is greater than 0 for all numbers in that particular interval. So if we choose one number in an interval and it's positive, every number in that interval is positive. If the value of f is negative, then f of x is less than 0 for all real numbers in that particular interval. If you have the less than or equal to or greater than or equal to 0, you want to make sure you include those values in the solution set. Again, you're going to write your answers in interval notation. Remember, you use parentheses for the less than or greater than, and you use the bracket. For the less than or equal to or the greater than or equal to. So for example, let's take a look at the first example here. X squared plus 8x is greater than 0. So we already have f of x, all the expressions is on the left-hand side, you have a 0 on the right. So what we're going to do is factor the left-hand side, so my GCF factoring, I factor out an x. So I can get it in factored form. Now I'm going to set each factor equal to 0. So I have x equals 0, x plus 8 equals 0. So then my critical numbers are going to turn out to be 0, and when I solve this, that gives me negative 8. So my critical numbers are 0 and negative 8. So what I'm going to do is I'm going to plot these critical numbers on the real number line. So there's my negative 8, there's my 0. Again, because it's just greater than 0, it can't be equal to 0. So I know that I am not going to include negative 8 and 0 in my solution set. So I'm going to put open circles over there. What I'm now going to do is notice my number line is divided into 3 intervals. Numbers less than negative 8, numbers between negative 8 and 0, numbers greater than 0. So what I want to do is I want to pick a number in each in particular interval. So I'm just going to pick negative 9, because negative 9 is less than negative 8. I'm going to take that value, plug it into the factored form of number. If it's greater than 0, I'm looking for positive numbers. So you don't need to actually find what the actual value is, just know if it's going to be a positive or a negative number. So I plug negative 9 in for x, that's going to be a negative number, times negative 9 plus 8 is another negative number. And when you multiply a negative times a negative, that's going to give you a positive number. So that tells me all numbers less than negative 8 are going to be positive. And remember, I want values greater than 0, so my positive values are going to be my solution. So at this point, I do know that the values less than negative 8 will be a solution. Now I want to pick any number between negative 8 and 0. When you're viewing your test number, 0s and 1s and negative 1s are the easiest numbers to work with. So I'm going to go ahead and choose negative 1. So I plug negative 1 into the factored form, negative x, negative 1, times negative 1 plus 8 is a positive. So a negative times a positive gives me a negative number. so I know I'm not going to have any solutions between negative 8 and 0. If I pick a positive number greater than 0, I'm going to pick 1. Plug in 1, that's positive, times 1 plus 8, which is positive, and a positive times a positive is a positive number. And again, positive numbers are greater than 0. So I know that my solution to this particular inequality is going to be all real numbers less than negative 8. So in interval notation, I'll be negative infinity to negative 8. And then all numbers greater than 0 from 0 to infinity. So that's how we can solve that particular inequality.